Welcome back to my rubber heart. Today we are zooming in on a star player in the rubber world, vinyl silanes. These incredible little molecules act as bridges between fillers and rubber. If you've ever wondered how compounds with silica gain strength and durability, vinyl silanes are often the secret sauce. So what are vinyl silanes? Think of them as a two-part connectors. One end clings to inorganic fillers like silica, glass beads, or minerals, and the other bonds with organic rubber through a vinyl group. It's like having a handshake between two different worlds. They are bifunctional. Hydrolyzable groups attach to fillers, and vinyl groups form covalent bonds with rubber chains. Now let's talk about fillers. Silica is a classic case. On its own, silica with its surface OH groups doesn't mesh well with nonpolar rubbers, but introduce vinyl trimethoxysilane, and the silane first reacts with the water to form silanol, which bonds to silica's surface. Then, during cure, the vinyl end cross-links into the rubber, creating strong chemical bridges, so the filler and the rubber act as one. The result? You will see improved dispersion, reduced viscosity during mixing, and much better dynamic performance. Less heat buildup, stronger tear resistance, higher tensile strength. That's why vinyl silanes are popular in tire treads for silica compounds and in high-performance EPDM or silicone rubber applications. But silica isn't the only one. Glass fibers treated with vinyl silane show better adhesion to silicone rubber or EPDM, making composite products stronger and more weather-resistant. They are also used as comonomers in moisture-curable polyethylene and EVA pipe systems, providing improved bonding to surfaces like glass or metal. Different vinyl silanes offer slightly different properties. Vinyl trimethoxysilane is more reactive and volatile, while vinyl triethoxysilane is gentler, offering slower hydrolysis and better stability for high-temperature mixing. Choosing between them depends on your cure system and process conditions. You want the silanization step, where the filler surface bonds, to occur without premature cross-linking during mixing. Now what about polymers? Vinyl silanes work best in non-polar, unsaturated rubbers, like NR, SBR, or BR, where the vinyl group easily participates in sulfur crosslink. They also help with EPDM and silicone rubbers, which otherwise don't bond well to fillers. Functional butyl and FKM can benefit too, though interactions depend on filler surface and cure chemistries. When compounding with vinyl silanes, keep a few points in mind. Mixing temperature needs to be carefully controlled. Around 140 to 150 degrees is typical to allow the hydrolysis and condensation steps without premature cross-linking. You also need moisture. No water, no silanization. Unlike sulfur silanes, vinyl silanes don't supply sulfur for cure, so they are often used in conjunction with standard cure packages. Master batches help here. They capture the silane and catalyst in a carrier, protecting it until mixing. In practical terms, when using vinyl silane in a silica-filled NR compound, expect better filler rubber coupling, which translates to enhanced tear resistance, reduced hysteresis, better abrasion, and overall improved rolling resistance in tires. In EPDM sealants with glass beads, vinyl silane improves mechanical strength, adhesion to metals, and moisture tolerance. Vinyl silanes are molecular matchmakers. They connect inorganic fillers with organic rubbers, improving dispersion, mechanical strength, durability, and dynamic performance. Using the correct type, depending on your filler, rubber, mixing conditions, and cure system, is crucial. With them in your compound, you unlock a level of performance you can get otherwise. That's the magic behind vinyl silanes. Simple chemistry, powerful results. If you would like to dive deeper into mixing curves, master batch formulations, or cure kinetics, let us know in the comments. Thanks for tuning into my rubber heart, and until next time, stay elastic and stay curious.